Section 4.2 Interactive Assignment Objective 1 using StatCrunch, where we're finding the least squares regression line using technology and answering the following questions. What we want to do for step 1 is to find the equation of the least squares regression line using technology using the data below here. Okay, so we have our first column, which is club head speed in miles per hour, and then we have our distance in yards. So I'm going to go ahead and open this up in a StatCrunch. Now, sometimes when you pull the data in from StatCrunch, the columns may need to be rewritten. So in here, this should be club head speed, and then the second column should be distance. So we can just easily change that by highlighting it and then writing it in. Okay, now the first thing we want to do is we want to figure out what is the least squares regression line using technology. In order to do that, we're going to select Stat, and then we're going to scroll all the way down to where it says Regression, and then select Simple Linear. We want to make sure the X variable is the first column, the explanatory variable, which is the club head speed. We want to make sure the second column, distance in yards, is the response variable, so we want this distance selected. Okay, and then we're going to scroll down just a little further until we get the following here, where it says horizontal lines and vertical lines. The reason why we're selecting that is because we just want to be able to see that when we look at the graph. So let's go ahead and select compute. So now selecting compute now is going to give us the following information. Now a lot of this information we're not going to need until later on in the course. So what I'm going to do is I'm just going to copy this part here, and then we can generate our equation. Okay, so this is our information. Okay, now before we do anything further, what we're trying to do is we're trying to find the least squares regression line. Now, I'm going to go ahead and write down some pertinent information. Now, remember that the slope-intercept form that you may have seen in the past is y equals mx plus b, where m represents the slope and b represents the y-intercept on where it crosses the the y-axis. Okay, now in our course, you're going to see that there's another way of writing this. We have y hat, which is equal to b subscript 1 x plus b subscript 0. Okay, b subscript 1 is the same thing as the slope. B subscript 0 is the same thing as the y-intercept. Also, in our technology, they also write it this way. We have y hat, which is equal to c1 x plus c0. Again, what this does is the same thing. That means the slope and that means the y-intercept. So don't confuse these particular variables. Just know that it's just set up the same way. Now the next thing we want to do is determine, okay, well the dependent variable is distance. And the dependent variable represents y because that is the dependent variable. Okay, and then the independent variable is the club head speed, which is x. X represents the independent variable. So if you notice in the equation we have the distance, which is y, which is equal to the y-intercept, and let me color that. This represents the y-intercept, which would be either b subscript 0 or c0, and then it's going to equal plus. Okay, now if you notice it's the independent variable, so it's going to be the independent variable's club head speed, and then we have the slope, and the slope is plus 3.1661017. So that's going to represent the slope. Now, if I wanted to write out this linear equation, it would be the following. It's going to be the distance, which represents y hat. Okay, now what I want to do is I'm going to take this number here and this number here, and I'm going to round it to 3 decimal places. So that 3.166 represents the slope. That's going to be 3.166x. And then you can see that the y-intercept in blue is a negative, so it's going to be minus 55 point, now we're writing that to 3 decimal places, which is going to be 796. So therefore, you're going to see the following. Again, we have our dependent variable distance, which is y. Okay, and then we have our slope, which is 3.166. We have our independent variable, which is x. And then we have the y-intercept, which is minus 55.796. Now notice down here, it also shows the intercept, which is the same number that we got there. And it also shows the slope, which we found there. So this is our least squares regression line. So this represents part 1. Okay. Now in part 2, we want to draw the least squares regression line on the scatter diagram of the data. Okay. So one way of doing this is the following. Now I'm going to open this up in the StatCrunch. Now if you move to the right, the line has already been fitted into this. Okay. Now let's say that we didn't have that and we want to be able to put this into our data sheet. So I'm going to go ahead and close out of this, and if I wanted to create the scatter plot and then put this equation in there, this is what I would do. I'm going to go to graph, this is step 2, I'm going to go all the way down here and select scatter plot. Again, I'm going to make sure the x variable is the club head speed. I'm going to make sure that the y variable is the distance. And then I'm going to scroll down a little further, and then you see where it says overlay polynomial order. What we're going to do is this is going to allow us to put this equation in there to create the line in the scatter plot. So I'm going to select 1 because that means it's a degree of 1, meaning it's a linear equation. Okay, we're not going to choose the other options because we're not using those in this class. So we're going to select 1, and then down here we're going to select this. Now recall that C0 represents the y-intercept. So I'm going to go ahead and put that in there, negative 55.796, and then C1 represents the slope, and that's going to be 3.166. Okay, and so now what I'm going to do is now I'm going to go down a little further. I'm going to make sure that the display is points, and then I'm going to go down a little further, and I'm going to make sure that the horizontal lines and the vertical lines are displayed. And now I'm going to select compute. Now you're going to see that this represents the same graph that we saw in that previous display. It's just another way of being able to graph that line on that. So I'm going to go ahead and copy this graph, and I'm going to explain this more into detail. Okay, so here is our graph. Again, this is step 2. Okay, now if you take a look here, we have our points. Right, so the first point here where it says 100, 257 is right there. So this is our ordered pair, 100 and then 257. This is the observed value. Observed is because it is the observed because we put this in a data table. So this is the observed value. Okay, so this represents number 2. We draw the least squares regression line on a scatter diagram of the data. Okay. Now, in part 3, it says they want us to predict the distance a golf ball will travel when hit with a club head speed of 103 miles per hour. Okay, so in step number 3, what we're doing is the following. We're going to use this equation that we have, which is y hat equals 3.166x, and then subtract 55.796. And what we want to do is we want to find the predict. Predicting means that we're going to take this value of 103, which represents the club head speed, and that is the independent variable. So that means that that's what x equals. So that means we're going to say x is going to equal 103, and then we're going to plug it into this equation. So if we take 3.166, multiply it by 103, and then subtract 55.796, then what do we come up with? Okay. Putting this in our calculator, we would end up getting 270.302. Okay, this is called the predicted y value. Now, we can also generate this information using StatCrunch. Now, let's figure out how we would do this on StatCrunch. Now, I'm going to go back and I'm going to open up in StatCrunch. Now I want you to see that when I close this, okay, there are two results that are hidden. The first one is the simple linear regression that we found, and then we had the scatter plot. We're going to go back to the information that we used for the first display. So you can just click on that and it's going to bring it back. And you can see that this line in this graph is the same thing as this one that we graphed. So we don't necessarily have to put this equation. I just wanted to show you that option. Okay, now we're going to scroll back here, and what we want to do is we want to figure out how to do this by using StatCrunch. So we're going to go back and select Options. We're going to go to Edit. Okay, and then what we're going to do is, you see where it says the prediction of Y? You see the X value in here. Okay, we're going to put in the value here of 103. Because it's automatically going to generate that value that we got here. So I'm going to now select Compute. Okay, now let's take a look at this display down here. Okay, so I'm going to go ahead, and if you notice, it gives us an additional item down here. So here's your X value, and then there is the predicted Y value. Now, if you notice, the predicted Y value is a little bit different than the one we got. And the reason why is because we were using the equation where we already rounded it to 3 decimals. So this number is going to be slightly off because this one's is not going to round anything at all. So therefore, this is giving us the predicted Y value. Okay, so now I'm going to copy this information that we got from our display. Okay, and so we're going to use the technology version of the value. So we're going to use the predicted Y value to be 270.31186. Okay, so what that means is that we plugged in the value of X. So that means that our X coordinate is 103 and our Y coordinate is going to be 270. We're going to just round this to 1 decimal place, 0.3, which would be the same thing for this one as well. Now let's plot this on the graph. Now this point is the predicted Y value using this equation. So this point is going to be right on the line. So looking at the graph, I'm going to move over 103 and then go up to the point here, and it's going to be right on the line. So that means that this is the predicted value. Okay? So therefore, we have 270.3. All right? So I'm just going to move this display down a little further so we can use this information here. So this is where our predicted Y value is. So we've completed part 3. We found that. Now we need to determine the residual for the predicted value found in part C. And then we need to determine, is the distance above or below average among all balls hit with a swing speed of 103 miles per hour. Well, recall that this line represents this equation. Okay, this equation represents the average because that's the line of best fit. And that's the one we just determined over here, 3.166x minus 55.796. Okay, and so now what we want to do is we want to find out, okay, what is this point right here? Well, this point is given in the table. And recall that the x coordinate is 103. Okay, this 103 has a y value of 274. It's the observed y, this is the observed because this is what's given in the table. Okay, so the observed now is going to be 103 and then 274. Okay, now for step 4, what we want to do is we want to be able to find the residual. So how do we find the residual? Okay, the residual is taking the observed y value and then subtracting the predicted y value. Okay, so what is the observed y value? Well, if you look here, it is 274. Okay, so let me highlight that. The observed y value is 274. And then the predicted y value is what we found in step 3, which is 270.3. So we're going to subtract 270.3. So therefore, the residual is the difference between those two numbers. Okay, so if we take 274 on our calculator, so 274, and then subtract 270.3, that gives us positive 3.7. So if you notice that this point lies above the line, which means it is above average, and the residual was 3.7. So therefore, we're going to say that the distance is above average. So we would say that it is above average. And that is using StatCrunch to answer the following questions.